4, we learned how to graph exponential functions. Here's one example. For this example, you're going to want to take out your calculator and click the y equals button and insert the equation. This equation is 3 times 2 to the x. When you get the equation, click graph and the graph will appear. Click second graph to get a table of the values of x and y for your graph. When putting this table on your paper, be sure to use only the whole numbers and a few smaller numbers for this equation, -2 to 1 would be perfect. Now that we have our table of values, we're going to want to put these numbers onto our graph. Start with your first number, -2 and 75 hundredths. So we're going to go to our graph, to the origin, go back 2, up approximately 0.75. It is okay if it is not perfect. Then we'll go to our next value, which is -1, 1.5. We'll start at the origin, move back 1, and go up 1.5. And on and on and on. So 0, 3. Start at the origin, and go up 3. And then for our final value, 1, 6. Start at the origin, go over 1, up 6. Now we're gonna connect those dots with a curve to make it most like the graph shown in our calculator. For exponential functions, we have a curved line on our graph. It's not perfect, but it's close enough. That is how you graph exponential functions.
Exponential growth and decay are both exponential sequences. The formula for exponential growth is y equals a, open parenthesis, 1 plus r, close parenthesis, to the x power, when y equals the end amount, a equals the initial amount when x equals 0, b equals the base or the rate, and x equals the exponent or the number of. You can use y equals ab to the x power. An example of exponential growth is when the base is greater than 1. Formula for exponential decay is y equals a, open parenthesis, 1 minus r, close parenthesis, to the x power, or y equals ab to the x power. A newly released car costs $20,000. The annual depreciation of this car is 10%. In 3 years, how much will the car be worth? This is an example of exponential decay because the base is less than 1. In order to get this base in exponential decay, you take the percentage and put it over 100, and then you take this value and you subtract it from 1.
Topic 4, Part 3, Modeling Exponential Growth and Decay. When putting an equation into the table, first you have to fill the variables in, which in this case are a equals 4 and b equals 5/10. After filling them in, you can put the equation into your calculator. First, push the y equals button, then punch in the numbers. Y equals 4, open parenthesis, 5/10, close parenthesis, up arrow, then x. And when you're done, hit second graph. When you put the equation into the table, all you should do is put in a few negative and positive x values, then the y values that correspond with the x values. Then you're done. For modeling an equation on a chart, it is very similar to filling out a table. First, you fill in the variables, which is a equals 4 and b equals 5, then put it in your calculator. First, hit the y equals button and enter the equation 4, open parenthesis, 5, close parenthesis, up arrow, then x. After, hit the graph button to see the graph, and second graph to see the table. When graphing, you take the coordinates from the table in your calculator and plot them on your graph. Once you have done that, you draw a line through the dots with arrows on both ends. Now you have completed it. Words to know. Geometric sequences are sequences that follow a multiplication pattern. Arithmetic sequences are sequences that follow an adding pattern. A geometric sequence is an equals a1 times r to the power of n minus 1. R equals the common ratio. Arithmetic sequences, the formula is an equals a1 plus, in parentheses, n minus 1, close parentheses, d. D is the common difference, adding or subtracting. Let's do an example. 5, comma, -1, comma, -7, comma, -13. Right off the bat, we have to find out if it's arithmetic or a geometric sequence. So from 5 to -1, that's subtracting 6. From -1 to -7 is also subtracting 6. So we already know that it's an arithmetic sequence, and d equals -6, a equals 5, since that's the initial amount. Now, to write the equation, we have to start off with the formula, an equals a1 plus n minus 1 d. And since we already know what d and a is, and we can't find out what n is because it's unlimited, this is the equation, an equals 5 plus 1, n minus 1 times -6. Another example, if f1 equals 11 and fn equals 3f, open parenthesis, n minus 1, close parenthesis, plus 1. Then find f4. First, the start is f1 equals 11. Previous is fn equals 3f, n minus 1 plus 1. And the goal is we have to reach the f4. So, first we have to start off with the original equation. f1 equals 11. Then we have to drop that down into this equation. So we go to the next number, f2 equals negative 3, 11 plus 1. Put that in your calculator, you get negative 32. Next, do the next question, or the next part, f3. Put that number, negative 32, into this equation. Negative 3, open parenthesis, negative 32 plus 1. Put that in your calculator and you get 97. Now let's go on to the next number, f4, which is what we're looking for. Negative 3, open parenthesis, 97 plus 1. Put that in your calculator, you get negative 290. f4 equals negative 290, and that's the answer.